Before we get started with our new lesson today, let's start with a review of what we did in our previous lesson, Lesson 10.3, the area of circles. The directions ask us to find the area of this figure, and we see in the lower left-hand corner of the screen a picture of a circle. Now remember, the formula for the area of a circle is pi times radius squared, and for the purposes of our calculations, we're going to use pi as 3.14. So here's what I'm going to substitute into my calculator. Pi 3.14 times radius, wait a minute, 60 centimeters isn't a radius. 60 centimeters is a diameter. So before we substitute into our formula, we have to take that diameter and cut it in half. So 60 centimeters is the diameter, half of that would be 30 centimeters. And 30 squared means 30 times 30. Let me go grab my calculator, and we'll see what 3.14 times 30 is equal to. Or in other words, 3.14 times 30 squared. And I get 2,826. Let's check the answer. Don't forget your label, 2,826 centimeters squared. So to find the area of a circle, just be careful that you need a radius for the formula, and sometimes you might be given the diameter. So our lesson today is about 3D space figures. First of all, let's talk about what we've been studying so far. So far, we've been studying 2D figures, two-dimensional figures. They're called plane figures. They have two dimensions, a length and a width. What we're going to start studying today are called solid figures or space figures. They have three dimensions. They have a length, a width, and a height. Here's some new vocabulary for you to copy into your workbook. Our local standards today are M7B.2.1, and you can see that our objectives are to identify common space figures and to identify the nets of space figures. If you have any questions on today's lesson, the lesson can be found in your textbook on pages 539 to 543. So let's get some new vocabulary out of the way. A space figure is a three-dimensional figure or solid. You can see that a space figure has two bases if it is a prism. It has one base if it is a pyramid. And there's our new vocabulary that you see there next. A pyramid has just one base that is a polygon. And the lateral faces are triangles. In the next two figures you see, and we'll see the definitions on the next page, if it has two circular bases, that's a cylinder. If it has just one circular base and one vertex, that's a cone. Let's get those two new vocabulary. A sphere, which we see pictured here next, is the set of all points in space that are a given distance from a given point called the center. A net, as you can see two nets listed below, is a pattern that you can form into a space figure. Please remember that at any time you can pause this video and get caught up on that new vocabulary before we go on to the next example. Let's take a look at some polyhedra. Polyhedra are solids with flat surfaces that are polygons. So what we're going to do is we're going to take all of the polyhedra that we see on this slide and we're going to drag them onto the orange mat. We're looking for things that have flat surfaces that are polygons. These are all called polyhedra. They have flat surfaces that are polygons. So essentially the ones that I'm left with are not polyhedra because they don't have flat surfaces that are polygons. This yellow figure on the left is a cylinder, has two circular congruent bases. This is a sphere, and the brown one here on the right is a cone. Now we're going to take those polyhedra that we just identified and further classify them now as a prism. A prism is a polyhedron with two parallel congruent faces called bases. Now wait a minute, there's a common misconception, and that common misconception is that those bases have to be on the top and the bottom. Not true. The bases do not have to be on the top and the bottom. Any two parallel polygons are the bases. So let's take those figures now that are polyhedra, that are also prisms, and drag them onto the black mat. We're looking for two parallel congruent faces called bases. and those are the figures that are prisms. Now as we turn to the next slide, we're going to take those prisms and put them back on our mat. And we'll then look at the figures that we were left with and see which of those that are left are called pyramids. Now remember, a pyramid is a polyhedron that has one base that is a polygon. Its other faces are triangles. So this would be a pyramid. This one is a pyramid, and this one is a pyramid. Now that we kind of have a general overview of space figures, let's see how we would name space figures. And we're back to the examples now that are in your workbook notes. For each figure, describe the bases and name the figure. So as I look at this figure in example A, I see that it has two bases, two congruent circular bases. So the bases are circles. The figure then, with two congruent circular bases, the figure, we would call that a cylinder. Oops. A cylinder. For example B, we have two congruent bases that are squares. And since there are two bases and not just one, that is a square prism. Let me position that better in the box. So two bases that are squares, and a perfect example of that common misconception we talked about on a previous slide. It doesn't have to be the top and the bottom that are the bases. In this case, it is the left side and the right side that are the bases. Now, as we look at example 2, we think through a very similar process. We look at the bases, the shape of the bases, and how many bases there are to help us name that space figure from the net. So in the next figure, I can see that it has two hexagons. So it has two hexagonal bases, and it has rectangular sides. So the space figure that we can form from that net with two hexagonal bases and rectangular lateral sides is a hexagonal prism. Hexagonal prism. And again, because it has two hexagonal bases and rectangles for the sides. In example B, it has one base. So right off the bat, I know this is going to be a pyramid with the triangular lateral faces. And it's kind of hard to tell if that shape of the base is a rectangle or a square. So it kind of looks like a rectangle. So with a rectangular base and triangular sides or lateral surfaces, we would call that a rectangular pyramid. A rectangular pyramid has one base that is in the shape of a rectangle, triangular lateral faces, that's a rectangular pyramid. To kind of wrap up everything we've talked about today, let's see if we remember which one of these figures, without seeing the picture, just by knowing what we've learned, which ones of these figures are polyhedra. As we drag them to the lake, if they are correct, the word will float. If they are incorrect, the word will sink. So a cube is a polyhedra. Okay, that floats, so it must be correct. A triangular pyramid. And let me just go ahead and grab these other ones that I think are. Pyramids and prisms are polyhedra. And the rest of these words are not. Just to prove that, I could try to drag one of them to the lake and oh no, it sinks. So it is not a polyhedra. So that was our lesson on space figures. Hopefully you learned some new vocabulary, how to name space figures, and how to identify space figures from nets. Please feel free to watch any part of this video again to help you better understand space figures. Thank you.